All right, what up, peeps? So today should be August 18th. That's when you should be watching this video. You should be watching this video during class and filling out the worksheet or the PDF that's available on Canvas as we go along. It shouldn't be very long, and let's get started. So these are all topics that you should know before coming into algebra. But if you don't understand them right away, it's totally okay. Just make sure that you see me during my office hours. Shoot me a quick email. Be like, hey, this topic was giving me some trouble. But for the most part, you should have seen most of this before, and we're going over it now. So if anything's a little bit fuzzy after this, I would be surprised. But if it is, it's no big deal. Just come see me, okay, when I'm back from my trip. All right, so the first thing that we're going to talk about is adding and subtracting, some basic addition and subtraction. So when you're adding two numbers together, you're combining their sums. Now, when we have negative numbers, for example, -9 being added with -15, you've got to be a little bit careful, but since they're both negative, we are going to add them together. So 9 plus 15 would give me 24. So we got 24, but since they're both negative, their sum needs to be negative as well, okay? Now, when you're adding two numbers where they have different signs, so this first 2 is positive and this second 3 is negative. When you add them together, you actually subtract them. So this is the same as 2 minus 3, which ends up giving me -1. It's -1 because the 3 was the larger number. Whichever number is larger when you're adding two numbers, that number is going to take whatever sign it was, and your answer is going to be that sign as well. So our answer for the second one was -1. I'll circle the answers for each. The first answer was -24. The third answer, we have 6 minus 9. Now, a lot of students now in today's day and age will take this problem and they'll say 6 plus -9. So what they do is they take this negative and they attach it to the 9 instead of reading it as 6 minus 9. And now we know, okay, the 9 is the larger number. It's negative, so our answer needs to be negative. They're different signs, so we're going to subtract them. So this would be 6 minus 9 or 6 plus -9, which would give me -3, okay? However you want to look at it, you can. Just remember, whenever you're subtracting a larger number, your answer should be negative. And whenever you're adding two negatives, if a negative number plus a negative number, your answer is also going to be negative, okay? Number 4, -6 minus 11. So this is -6. We can rewrite it as plus -11. They're both negative. We're going to add them together. 6 and 11 give me 17, and our answer should be negative. Okay? Number 5, we have 13 plus 8. This is standard. They're both positive. This is just general addition. You add 8 to 13, you're going to get 21. And number 6, we have -12 minus -10. Now remember, we are going to try to write this as an addition problem, so it's going to be -12. When you subtract a negative number, you're actually adding that number, because whenever you have two negatives next to each other, they're going to cancel out and become a positive, okay? So it's going to be -12 plus 10. The 12 is the larger number, and it's negative. We're going to subtract them because they're different signs, and we're going to get -2, okay? Just some basic addition and subtraction with negative numbers. Then we're going to move on to multiplying and dividing, okay? So in algebra, the algebra that we're going to see, you're going to see this a lot where there's no operation, okay? I want you to write a little note to yourself, and I expect to see it in your notes written down as well. The only invisible operator is multiplication. Okay? Now, your operators are addition, subtraction, multiplication, and division. Now, for three of them, addition, subtraction, and division, you need to have the operation needs to be written down. Now, for multiplication, sometimes it doesn't. For example, there's no operator going on between the 2 and the -7. But whenever you have a number next to parentheses, it always means multiply. So we're going to take this to multiply it by -7. 2 times 7, 2 times a positive 7 gives me 14. And whenever you have a positive times a negative, you're going to have a negative, okay? Positive times negative gives you negative. Positive times positive gives you positive. Or negative times positive gives you negative. And two negatives multiplied by each other give you a positive number. Okay, so when the signs are the same, you're going to stay positive. When the signs are different, you're going to turn into a negative. Okay, so same in the next one. This also means multiplication. You'll see it be written as a dot, or sometimes it'll be written as an X, but we're moving away from the X in high school algebra. Okay, so when we have negative 8 times 2, 8 times 2 is 16. And since it's a negative times a positive, we're going to have a negative there. So negative 16, okay? Now, for a lot of you guys, if this is super easy, you can speed up the sound of my voice. You can click on, in YouTube, you can change the playback speed, and you can speed this up. Make sure you get it all written down. If you want to try out some problems and then check whether you're right, that's perfectly fine as well, okay? Moving on to number 9. We've got 9 divided by 3. That's just a standard problem. They're both positive. We have the same sign, so our answer is going to be 3, which is positive, okay? Now, division just means how many times can that number go into the original number. So 9 divided by 3. 3 plus 3 plus 3 gives me 9, so that was 3 times, okay? Number 10, we have 25 divided by negative 5. Remember, this is a positive 25. This is a negative 5. So our answer, we already know off the bat, is going to be negative because they're different signs. 25 divided by 5 is 5, so our answer is going to be negative 5. Number 11. In number 11, we have negative 30 divided by negative 6. Remember, two negatives. Since we're dividing, our answer is going to be a positive value, and it's going to be positive 5. Now, a lot of the times they're not going to write that plus sign in front. They're just going to write your answer as 5. This is the proper notation, okay? So our answer is 5. Number 12, we have negative 1 times negative 7. Remember, no operator means that it's multiplication, okay? So we have negative 1 times negative 7. That's two negatives multiplied by each other. We're going to get a positive 7 here. 1 times any number will be the same number. All right, moving on. All right, guys, I want you to add one more problem in here. So let's go ahead and we'll make it number 13 and 14, okay? For number 13, we're going to go ahead and multiply two fractions. So for example, let's say we have negative 2 times 3 over 7, okay? So you'll notice 3 over 7 is a fraction. Negative 2 is not a fraction, but you can always change any number, any whole number, into a fraction if it's not already, okay? So negative 2, we can write it as negative 2 over 1, because dividing by 1 is not changing the value of any number. Anything divided by 1 is just that same number. So negative 2 divided by 1 is still negative 2. So we can write it as negative 2 over 1 times 3 over 7, okay? Now, when you multiply fractions, do not cross multiply, okay? You multiply straight across. So we take this negative 2, we multiply it by the 3. Negative 2 times 3 will give me negative 6 in my new numerator. Then I take my two denominators, which are the bottom numbers, and I multiply those by each other. So 1 times 7. 1 times 7 is just 7, so my final answer is going to be negative 6 over 7, okay? Let's do one more. So we've got 14. Let's also multiply two fractions. Let's take negative 2 over 3 times 5 over 4. So again, they're both fractions, so we don't need to change any of them. Multiply straight across. So negative 2 times 5 will give me negative 10, and we'll have 3 times 4, which gives me 12 in the denominator. So negative 10 over 12 is our answer. You should always look, though, to simplify, okay? If they have a common factor. So 6 and 7 had no common factor, so we couldn't simplify that top one. 10 and 12 have a common factor of 2, so you can simplify this. You can divide the numerator by 2 and the denominator by 2. This is considered simplifying your fraction, okay? Negative 10 divided by 2 is going to give me negative 5 in the numerator, and 12 divided by 2 is going to give me 6 in the denominator. Now, 5 or negative 5 and positive 6 have no common factor, so it can't be simplified. So this is our final simplified answer. Okay. Let's do two more, but this time for 15 and for 16, we are going to divide fractions, okay? So let's take the exact same problem. We had negative 2 over 3, but we're going to put a division symbol, and then 5 over 4, okay? Now, when we're dividing fractions, we follow a methodology called keep, change, flip, and I write it every single time, okay? Keep, which is our K, just means keep it the same. So we're going to keep the negative 2 over 3 the exact same. Change means we're going to change this division symbol. We're going to change it into multiplication, okay? And then flip means that we're going to completely flip our fraction on the right-hand side. So this 5 over 4 will become 4 over 5, okay? Now we have a multiplication of fractions problem. We just multiply straight across. Negative 2 times 4 gives me negative 8. 3 times 5 gives me 15. Now, always check, can you simplify? 8 has factors of 2 and 4, 1 and 8. None of those are factors of 15. 15's factors are 3 and 15 and 1 and 15. So there's nothing that or 3 and 5, excuse me, and 1 and 15. So we're going to box this in. It cannot be simplified, okay? All right, let's do one last one. Our last problem is going to be negative 9 over 5. This is number 16, negative 9 over 5. And we're going to divide it by 2, okay? Now, let's go ahead and rewrite this. Before we start to keep, change, flip, we got to rewrite this. So we're going to write negative 9 over 5 divided by, we're going to change 2 into 2 over 1, okay? We want to make both sides, or both numbers or integers, we want to make them fractions, okay? All right, so now we're going to follow the KCF, keep, change, flip. We're going to keep negative 9 over 5 the exact same. So just rewrite it, change division into multiplication, and go ahead and flip this guy over here on the right side. So we're going to flip 2 over 1, and it's going to become 1 over 2. Okay, so once we keep, change, flip, now we just multiply straight across. So you're going to take this negative 9, multiply them by 1. Negative 9 times a positive 1 is going to stay negative 9. 5 times 2 is going to give me 10. There's nothing that's a common multiple, or there's no common factor between 9 and 10. So this is your final answer, negative 9 over 10. Perimeter and area, okay? So perimeter, we should already know. That's the distance around an object. Okay, for example, if we have a rectangle where these two sides are the lengths, this is the width, all you would need to do to find the perimeter, right, perimeter equals the length plus the width, going from here to here, then to here. You add those two together. You have to go along this way, which is also another L, or the length, and then you also add the width, okay? So in other words, we're adding all of these together. So you're adding the length with the width, with the length, with the width. In other words, specifically for a rectangle, we've got 2 lengths and 2 widths, okay? All right, and then area is it's formally defined as the space an object or a figure takes up. Okay? So in other words, the area, we'll draw a different figure. Let's draw a triangle. Okay? The area of this triangle is how much space does this triangle take up? In other words, the highlighted portion. That is what we call the area, okay? How much space does a figure take up? Now there's different formulas for different areas. For the area of a triangle, area is going to be equal to 1/2 base times height. Now on the SAT, on the ACT, they give you these area formulas, so I will be giving them to you as well, but you do need to know how to apply them. So you do need to know that the B in the area formula for a triangle means the base, and the height is the distance from the top of the triangle down to the bottom. Now we'll cover these more when we get into word problems where they involve triangles and rectangles and stuff in the area formula. But for now, you just need to be familiar with the two formulas, which is perimeter, which is this distance around an object, and the area, which is the space that an object takes up, okay? So let's try number 13. The length of a triangle is 6 feet and the width is 3 feet. Find the perimeter of the rectangle, okay? So again, a rectangle, you should know what a rectangle is. It's a quadrilateral where the length and the width aren't necessarily the same. If all the sides were the same, then that would be a square. So a rectangle where this longer side is 6 and its width is 3. So this side's also 6 and this side's also 3. So it says find the perimeter of the rectangle. So remember, the perimeter is the distance around the figure. So this would be 6 plus 3 plus 6 plus 3. So we're adding up all the sides. Our perimeter is going to be 6 plus 3 plus 6 plus 3. Perimeter equals 6 plus 3 gives me 9. 6 plus 3 gives me 9. So we have 9 plus 9, which gives me 18. So the distance around the entire rectangle is 18. Always include the units, and we were using feet for both of these, so our answer is 18 feet. All right, one side of a square measures 9 centimeters. Find the area of the square. So remember, a square is a figure where all of the sides are the same length. So we have 9 centimeters, 9 centimeters, 9 centimeters, 9 centimeters. Now for this type of problem, it would tell you that area of a square is the length times the length, because all the sides are going to be the same. So we have to take the length of one of the sides, which is, they're all 9. So we do area equals 9 times 9, which gives me 81. Now, the one thing in regards to area, you probably want to highlight this, is that you're going to write centimeters squared. Now, the reason we write centimeters squared, let's highlight this, is because area is the space that it takes up. So it's not one-dimensional, okay? It's actually two-dimensional, because it's how much space does this square take up. It's not a unit, it's not a length anymore. We're talking about space now, so it's going to be squared. Okay? All right. Next, we're dealing with the number line and the absolute value. Okay, so a number line is just a line where you have numbers on them, and it tells you where on the number line that you are. For example, 0 is here. All the positive values, 1, 2, 3, 4, are going to lie to the right of 0. And all the negative values, -1, -2, -3, are going to lie to the left of 0. Now let's go ahead and figure out, okay, what do those dots approximately represent? So let's start with the one all the way on the left, the yellow one. This yellow dot represents -4, okay? It's exactly on -4, okay? So that would represent -4. Now this orange one is somewhere very, very close in between -1 and -2. So I would say that this value is approximately -1.5. Now, I'm not going to ask you to be super perfect. If you put -1.4, -1.6, absolutely, totally cool, okay? So it doesn't have to be perfect. Now, for this next one, we have, it's somewhere between 0 and 1, but it's definitely closer to 0 than it is to 1. So we could write 0.1, 0.2, 0.3. Again, these are approximations. They don't have to be perfect, okay? But make sure it's not bigger than like 0.4, because it is significantly closer to 0 than it is to 1, okay? Now, let's go ahead and take those two as well, and let's write them as fractions. So, for example, this -1.5 could also be written as -1.5, because it's -1 is right here, but we're going past -1 about half a unit, so -1.5, okay? Over here on the right-hand side, we've got this purple dot, which is just slightly more than 3. So if I were to guess, I would say this is approximately 3.1, maybe 3.2, okay? Again, not gonna be super picky, just make sure that you realize it's not directly on the 3, it's a little bit past it, and the last one's pretty easy, that lies directly on the 5, okay? So this is a number line. Whenever you have a dot on the number line, it's representing a number, okay? Or a decimal or a fraction. All right. So -4 would be over here, right? -10 is somewhere down over here, way past it. Numbers to the right on the number line are larger than numbers to the left. So if we go back, moving on. Okay, so when we're talking about number lines, sometimes it's beneficial to determine whether something's bigger or smaller or equal to, okay? So we're gonna use these 3 symbols to complete these statements, okay? So 3 is a number that's smaller or less than 7. This symbol is the less than symbol, okay? As it's read, you're saying the number on the left is less than the number on the right, okay? Now, how a lot of students like to think about it is they draw a little alligator here. This is a mouth, and the mouth wants to eat whichever number is larger. So the mouth wants to eat the 7, okay? Because the 7 is bigger than the 3, okay? This symbol over here is the greater than symbol. So it's read as the number on the left is greater than the number on the right. And this is just an equal sign, okay? All right, so number 20, -1 is less than 4, okay? 4 is positive, 4 is a larger number than -1. Remember, any positive values are greater than any negative values. Okay, now we get to -4 and -10. Now, although 10 is a larger number than 4 is, when we're talking about numbers being negative, -4 is actually further to the right on the number line. If we go back to the number line slide, we're gonna say -4 is greater than -10. Because -4 lies to the right on the number line than -10, okay? And then for number 22, okay, so we're dealing with what's called an absolute value. I'm not going to go into too much detail about this, but absolute value essentially means that it's the distance a number is from 0. In other words, when you have the absolute value of something, no matter what sign it was before, just change that sign to a positive. So the absolute value of -6 is going to be +6. And we're comparing 6 and -3. So 6 is clearly bigger than -3. So we would write the absolute value of -6 is greater than -3. Please write in your notes that this symbol means absolute value. Okay? Now, I know you guys should have seen this before. If you haven't, do not freak out, okay? Just please come see me during my office hours. Make sure that you can look these symbols up online. You can look up these topics online. Khan Academy is a great resource, but please do not start freaking out. Don't start like calling all your friends, being like, do you guys understand this? If you haven't seen this before, I'm not worried. We do touch on this, but we go through it pretty quickly. So it's good that you're seeing it now, okay? All right. And if you've seen all of this before, that's awesome. Okay, next we're gonna evaluate expressions for variables, okay? Now, my biggest thing is that whenever we are, I call it plugging in, okay? Whenever we are evaluating for a variable, always evaluate with, and the magic word here is parentheses. Always evaluate with parentheses, okay? Now, what that means is, whenever we are plugging in a value for a variable, for example, these two examples deal with x, we are going to plug in for x with parentheses. So check it out. We're going to rewrite this problem. It's 2x minus 6, and then there's a semicolon. That means that there's a separate statement. It's saying x is going to be set equal to 9. So wherever we see an x in our original expression, this is our expression, 2x minus 6, we're going to replace it with a 9, okay? So we're going to write 2. Instead of x, we're replacing it, we're evaluating it as 9 minus 6. Okay? So we're plugging in 9 for x. Now, always add those parentheses because now that we've added the parentheses, this becomes a multiplication and then a subtraction problem. Okay? Now, remember, you're going to have to remember something called PEMDAS. Some of you might have learned it as please excuse my dear Aunt Sally. Okay? So in other words, we do whatever's inside. This P stands for parentheses. This E stands for exponents. This M stands for multiplication, division, addition, and subtraction. This is the order that we go in, okay? So we're going to look at this problem. We're going to say, okay, are there parentheses? There are parentheses. Now look inside the parentheses. We're still in this P. Is there anything inside the parentheses that we can simplify? The only thing inside the parentheses is a 9. And you can't simplify a 9. A 9 is just a number. So we're done with the P. Are there any exponents? There are no exponents. So we're going to put a check mark there. We're done. Is there multiplication? There is multiplication. This 2 is being multiplied by the 9. Okay, because it's, remember, there's no operation between the 2 and the 9. So therefore it has to be multiplication. So 2 times 9 is going to give me 18 minus 6. So we took care of the multiplication. Is there any division? Nope, there's no division, so we're done with division. Is there any addition? Nope. And subtraction. So now we finally subtract. There is subtraction here. So we have 18 minus 6, which gives me 12. We're done. Okay? All right, let's do another one. So we've got 24. Again, here's our expression, and we've got x equals 3. Now remember, when we're plugging in, always plug in with parentheses. So we're going to do -7 plus 9. Plug in with parentheses. We're going to put a 3 here. Okay, so wherever there was an x before, we put parentheses. We put what x is equal to, which is a 3. So now let's follow our order of operations. PEMDAS, please excuse my dear Aunt Sally. Parentheses. We're good because it's just a 3. There's nothing to simplify there. Are there exponents? No, we're fine. So we move on. Is there multiplication? There sure is. So we have to take the 9 and multiply it by the 3. So we're going to get -7 plus 9 times 3 gives me 28. And I move on. Is there any division? Nope. So we move on. Is there any addition? Yes, there is. So we take -7, add it with 28. In other words, 28 minus 7. That'll give me a 21. It's going to be positive because the 28 was larger. So we're donezo. There was no subtraction either. Okay? So remember, PEMDAS tells you which operations to do first. It's quite oftenly known as the order of operations. And let's do one more. All right, so we have 12x plus 13, where x is equal to 5. Let's take this 5. We're plugging it in for x. 12, always put parentheses when you're evaluating. All right, we're not going to walk through every single step. We know that this multiplication happens before the addition. So we're going to do 12 times 5, which gives me 60. And then we're just adding 13 to it. 60 plus 13 gives me 73. All right, now guys, again, if this is new to you, do not freak out. Just follow along. Take as good of notes as you can, okay? Write down some key pointers of stuff that I've said in the video that you want to remember, okay? But again, this is not like these assignments aren't going to be graded in the beginning for correctness, okay? This is just to see where you're at, all right? So if anything is like really, if like the whole thing you've never seen before, you need to come see me. But if it's like 1 or 2 topics, please don't worry about it. We do cover it when we cover the different lessons. I'm just going over these things that we should be familiar. Those of you that probably didn't do any math over the summer, this is just a refresher, okay? All right, our next topic is something called the coordinate plane, okay? That involves the x and the y axes, okay? This red axis that you see, that is horizontal. That is called the x-axis, and you'll see it labeled with an X. The vertical axis, which is labeled with a y, is what we call our y-axis, okay? Now, a lot of the times we're going to be using these axes to plot points, okay? So it's telling us to plot these 4 points on this axis, okay? What you need to know is that your first coordinate or portion of your coordinate is your x value, okay, or your x coordinate. Your second value is your y coordinate. So let's take the first one, for example. A is going to be located at 4, 2. So our x value is 4 and our y value is 2. That means on my x-axis, I'm going to go 4 units, okay? So on my x-axis, on the red horizontal axis, I'm going to find 4. Okay, so I found 4. So this is my x component, and my y component was a positive 2. So I'm going to go ahead and find 2 on my y-axis. It's right here. And then wherever they meet, so if we were to extend this line this way, and we were to extend the red line this way, do you see how they meet at this point? This is where we label point A, which was 4, 2, okay? It's 4 units in the x direction and 2 units in the y direction, 4, 2, okay? Let's do B. So B, its x component is -1, and its y component is 3. That means we're going to find -1 in the x-axis. That would be right here, okay? Because 2 units would be right here, so we're only going -1 unit in the x direction. And then it's 3 units in the y direction. So 3 units in the y direction would be up here. Even though it's not labeled, okay, it is 3 units above. So 1, 2, 3. And our point for B would be right here. We're going to label that B. It's -1, 3. All right, for C, we've got -5, -3. -5 is our x component, and -3 is our y component. So on the x-axis, we're going to find -5. -5 is right here, just to the left of -4. And then we're going to find -3 on the y-axis, -3. If we were to extend these 2 lines, do you see how they're going to meet up right at this point, which we'll label C? So C is all the way over there. And then 32, we've got D. D is at 3, 0. So we're going to go 3 units to the right for our x-axis. Our x component is 3. Now our y component is 0. What does that mean? That means that you don't move up or down at all. You're going to stay on the x-axis. So our last point is going to be this one, 3, 0, because your y value was 0. Okay, so this point is D. Again, guys, we will touch on this a bit more later on, but just getting you reintroduced to this stuff right now. All right, peeps, you finally made it to the last page. Okay, so we've got something called PEMDAS. We touched on this before when we were evaluating expressions, okay, but we're going to fill it in now just for our notes. So remember, the P in PEMDAS stands for parentheses. I'm pretty sure I'm spelling that wrong, but whatever. I teach math, not English. E is for exponents. M is for multiplication. D is for division. A is for addition. S is for subtraction. Ooh, boy. Subtraction. And that's it, okay? This tells you the order we move from top to bottom, from P to S, in what order to look at your expression. So what do you evaluate first? So let's take a look down here. First thing we're looking for are parentheses, and we sure have parentheses. Our parentheses are right here and right here. Now, all you're looking for parentheses is what's inside the parentheses. Is it simplified? -3 is inside the parentheses. There's nothing to do there, okay? -3 is just an integer. It's just a number. So we can't do anything. So parentheses are taken care of. Next thing we look for are for exponents. So look for your exponents. I notice that we've got an exponent here, an exponent in 2 to the second power. So let's go ahead and evaluate that. 2 squared, or 2 times 2, is going to be 4, okay? So we're going to rewrite the whole thing. Instead of 2 squared, we're going to write 4. So 14 divided by minus 4 plus negative 3 times 2 minus 1. After exponents, we are looking for multiplication. There is a multiplication symbol. It's right here. So we're going to go ahead and take negative 3, multiply it by 2. You're going to get 14 divided by 7 minus 4 plus negative 3 times positive 2 is going to give me negative 6 minus 1. After that, we're looking for division. So go ahead and take care of that division symbol right over here. So 14 divided by 7 is going to give me 2 minus 4 plus negative 6 minus 1. After that comes addition. There's only one addition symbol. It's right here. And we're going to go ahead and add negative 4 with negative 6. So it's going to be 2. Ooh, boy. It's going to be 2 minus 10 minus 1, because negative 4 minus 6 gives me negative 10. And now, last but not least, we've got our 2 subtraction symbols. 2 minus 10 is going to give me negative 8, minus 1 gives me negative 9. So my answer is negative 9. Okay, I want you guys to try the next one on your own, and then we'll go, I am going to go over it. So pause this video, try this one on your own, and then when you're ready, play the video to see if you got it right. All right, so based on PEMDAS, we're starting with parentheses. So there's 2 sets of parentheses here. There's this set of parentheses, and there's this one. This one, there's nothing to do here because it's just a negative 12. But there's some other stuff that's going on in this one that we have to be careful of. So we're going to take PEMDAS all over again, but inside now the parentheses. So we're just looking at inside the parentheses. I notice exponents, so we're going to evaluate this exponent first. So it's going to be negative 4 minus 3 plus 6 squared is 6 times 6, which is 36, divided by 13, minus 1 squared times negative 12. We're still inside the parentheses because parentheses come first. 3 plus 36 is going to give me negative 4 minus, and it's going to be 39 divided by 13 minus 1 squared times negative 12. All right, now that my parentheses, inside my parentheses is a 39 and a negative 12. So there's nothing further to simplify inside of them. Next, I look for exponents. So my exponents, there's only one of them now, and it's this negative 1 squared, okay? So we're going to take 1 and we're going to square it. 1 squared is 1. 1 times 1 is just 1, so it's going to be negative 4 minus 39 divided by 13 minus 1 times negative 12. Okay, so we took care of the exponents. Next comes multiplication. There's one multiplication symbol. It's this negative 1 times this negative 12, which will give me a positive 12. So we've got a positive 12, so it's going to be negative 4 minus 39 divided by 13 plus 12. Okay, moving on. Next comes division. So we've got to divide. So this is negative 39 divided by 13. That goes in evenly. It's going to be negative 4 minus 3. Goes in 3 times, plus 12. Negative 4 minus 3, we take care of, we take care of addition next. So we're going to add negative 3 with 12. It's going to be negative 4 plus 9. And then we go ahead and add those two together. That's going to be negative 4 plus 9, which is positive 5. You should have gotten an answer of 5. All right, we're down to the last topic, peeps. Greatest common factor. I know you guys are tired. Come on, bear with me. This is the last one, okay? So your greatest common factor is a factor. It's the largest factor, for both numbers. Okay, in other words, it's the largest factor that both the numbers have in common, all right? So sometimes it's just very helpful to break down all the factors of the number that you're looking at. For example, 45, okay? So let's just think about all the factors of 45. I know that 15 is a factor of 45, 15 times 3, okay? Then we can go ahead and do maybe 9 times 5. 45, it's not divisible by 4. It's not divisible by 7. Those might be the big two. We'll also write down 45 and 1, okay? Now, on the other hand side, we have 9. So we're looking at 9. Its factors are, well, obviously 9 times 1, and we have 3 times 3, okay? So now the only factor, or excuse me, they have two sets of factors in common. They both have a 3, and they both have a 9. Do you guys see that? So but their greatest common factor okay, so the common factors are 3 and 9, but again, we're looking for the greatest common factor. So our greatest common factor would be 9 because 9 is larger than 3, okay? All right, let's do the same thing. So we're finding the greatest common factor between 64 and 48. So the factors of 64, I know that 8 times 8 gives me 64. We should always start with 64 and 1. I know that 16 is a factor of 64. 16 times 4 is 64. Anytime you have an even number, 64 is definitely an even number, it's always divisible by 2. So I know that 64 divided by 2 is 32. So 2 and 32 are also factors. And I believe that's all of them, okay? So we've got those factors. Now let's do the same thing, but for 48, and let's see what they have in common. Okay, so 48. Obviously, let's start with 48 and 1. Then it's also an even number, so it's always divisible by 2. It's 24 and 2. It's divisible by 3. If you took 16 and multiplied it by 3, you would get 48. It's divisible by 4. 4 times 12, or 12 times 4, gives me 48. 6 times 8 also gives me 48. And these are all the factors, okay? So now when we're looking at the ones that it has in common, it has, oh, I forgot to highlight, excuse me, for the last one, 1 was also a common factor between 45 and 9. So I see the 1s, they have 8s in common, the 16s are in common, the 4s are in common, and the 2s are in common, and that's about it, okay? So the greatest of these common factors is the 16. So the greatest common factor of 64 and 48 is 16. All right, 2 more peeps, and then we're donezo. All right, we've got 25. 25, its factors include 25 and 1. Always start with that one. And I believe the only other one is 5 and 5. Okay? 10's factors are 10 and 1 and 2 and 5. The greatest common factor here, we've got 1's in common and 5's in common. So our greatest common factor, 5 is clearly larger than 1 is, so our greatest common factor is 5. All right, for 73, we've got 29 and we've got 12. 29's factors. So you always start with 29 and 1. And if you're having trouble coming up with factors of 29, other than 29 and 1, that's a good thing. 29 is what we call a prime number. It has no factors other than itself and 1. So we're going to stop there. And 12 has a few factors though. 12 has 12 and 1, and it also has 6 and 2, and it has 4 and 3. 4 times 3 gives me 12, 6 times 2 gives me 12, and 12 times 1 gives me 12. The only common factor between these two is the 1. So these two's greatest common factor is uno. All right, that's it. So these are topics that you should have seen before. Are you expected to know them right off the bat? No, okay? You're supposed to have seen them before. Now, how I teach is I'm going to go back, and every single time we go through a lesson, I'm going to retouch on these. But you need to, if some of this you've never seen before, like this is literally the very first time that you're seeing this, you need to come see me during my office hours because we need to refresh that material, okay? If some of this stuff you've seen before but you've never really understood, come and see me during office hours, okay? We've got to work hard to get everyone caught up on the same page, and then we can have some fun, all right? So make sure you took these notes. Make sure, guys, you are turning these into Canvas. So once you get it submitted to Canvas, what I want you doing with the rest of this period is working on your About Me, okay? That's the assignment that I gave to you guys yesterday before class ended. Just tell me a little bit about yourself, create that About Me one-pager. It's pretty simple. You can do it on Google Slides, you can do it on PowerPoint, however you want to do it. Just make sure you convert it to a PDF as you're submitting to Canvas. Because Canvas won't accept it unless it's a PDF. All right, that's pretty much it, guys. If you're done with both of those, then I have opened up the worksheet that's due on Monday. That is assigned as classwork for tomorrow. So tomorrow, all day, you guys are working on that. It's related to these topics that we covered today, just for you guys to get some practice in, to get your reps. And then I will be back on Monday where we will start our first official lesson of algebra. And I'll take any questions you guys have from these lessons, okay? But again, if this stuff is completely new to you, come to office hours. If you've seen it, you're just like, I'm not sure I quite understood, go back, rewatch the video. You can still come to office hours. I'm encouraging everyone to come, but don't freak out if you don't understand this, okay? That's the worst thing that you could do, is just freak out, all right? I will see you guys on Monday.